Hello, welcome everyone. It's great to have so many people here. I see a lot of colleagues in the audience. Yesterday, we did a trial run of this whole talk in a beer garden outside, and colleagues asked me repeatedly what I was going to talk about. And it was this back and forth between being so joyful and being so down. And so we've talked about lots and lots of different things. We've talked about German food, but yeah, as a disclaimer, it's not going to be an easy topic, right? It's going to be heartbreaking. And we're always confronted with how do we convey these topics properly? And me, as a meteorologist, I can only talk about the facts, right? I can only show what we see in our data, and that's my job. But within this field, the weather, the climate, the role that the climate plays is increasing, but really it's inseparable from the other. They're interlinked, right? We don't talk about any form of statistics. Of course, we have data, we have statistics, we have a reference point that we compare to the present. So how much warmer is it today in comparison to 1961 to 1990? For example, on the April 6th, we've had 30 degrees Celsius in Germany, and that's the first. That never happened before in Germany. And you can only know that if you know the statistics. But by now, we live in a reality that's different from our reality 40 years ago. Our atmosphere is different than 40 years ago, and we have to convey and display that new reality in the weather reports as well. And so I want to give you some facts, but I don't want to leave you frustrated at the end of the talk. So maybe we'll have some humor in the middle of it, but first of all, there's going to be some cold, hard facts. And really just like soak them in, and then afterwards, you can think about how do you want to deal with that. And I think it's very important that you don't consume these facts as an individual on your own, in your flat, in your apartment. You have to look for people that you can talk to, and you have to communicate with other people. And I think that's my approach to, handle all of these facts. And that's not easy, right? Especially when there's other people who are like, those facts and figures are all wrong. You're not a scientist, you're an activist. And I've brought something by Isabel Schneider, which is 6 minutes long, and I'm going to show that to you later on, how it feels to have to convey all of these facts and how strange this is, this place that we're in right now. Because meteorologists, climate scientists, since the 90s, we've known that this isn't something that's new. All of this misinformation, that the claims that there's just some people try to push this agenda of misinformation because of personal interests or various motivations. I really don't know why people would, be science deniers. And I want to talk about that as well. Yeah, so I'm going to have a sip in a moment, and maybe we can start with the first picture. Yeah, that's not the way I expected it to look, which usually happens, right? All right.
Keine Präsentation ohne Probleme.
There's always something. All right, so what do we see here? When I showed this picture at a different presentation, they were like, is that an error in the image back there? It's like mostly black, right? But in the middle of it, there's something blue. And when I first saw this picture, it was totally overwhelming for me, because this, pixel error in the middle, that's Earth, and at when do we see it from at such a long distance? This is from the Artemis mission from NASA, where they sent a spacecraft to the moon and took this picture looking back. And so this little blue marble is where we live. It's like traveling through time and space. And when you really conceptualize the fact that we're living there and, like speeding through space, right? It's just eerie, right? It's such a strange feeling because I don't even want to think about what, might be in our way. And of course, there isn't anything in our way there, but it's so fascinating to think about this. And so all of our assumptions day to day is so far removed from the reality that we're living on this planet and the distance between us and nature. So, for example, if you think about maybe, outside the sun is shining, the sky is blue, and you look up and you feel like it's just, there's no end to it, right? It's just such a giant open space. And then, and us, we're so small down here on Earth. And so I've learned that, here at Republica, there's lots and lots of questions and answers back and forth. So one question, did you travel 12 kilometers today? Please raise your hands, no matter what mode of transportation. 12 kilometers. Yeah, some people probably just toppled out of their hotel and had a short way here. Yeah, so 12 kilometers, horizontally speaking, that's nothing, right? You get in your car, travel for 12 kilometers, you're there shortly after. But 12 kilometers vertically, that gets us to the troposphere, and that's way harder to do. And so for me as a scientific, as a meteorologist with an academic background, with a diploma, that's different from someone who just, viewed 3 videos on YouTube and then afterwards feels like, oh, they're smarter than all of physics and climate science. So yesterday I met Harald Lesch, a famous German scientist, and I feel like, you have to talk about that. That's just the way it is. That's why I'm up on stage here. I'm trying to convey information. I'm trying to explain something to you. And I think that belongs together because people, that's a lot of criticism that you get that, you talk too much about climate and push it to the foreground. But really, it's the major topic of our times because what happens on that picture on the planet Earth, that's something we're responsible for. And so within these 12 kilometers, that's where the weather happens. And so, I'm going to continue. Something you have to understand, global warming. I'm not going to talk about climate change because, that's cute, right? It's like, oh, somewhere on the playground something happened and now you have to go fetch your kid. And that's way too weak of a term for the phenomenon we're describing. And so global warming is happening because of a mechanism I'm going to explain to you now. And a lot of people who deny science, they say, oh, that's just because of the sun. Yes, thank you. I know very much that, the rays from the sun bring warmth to the earth. But and so of course it plays a role, right? Without the sun, the planet Earth wouldn't be the way it was. It wouldn't be blue, probably. But the rays from the sun passes through all of these levels of air, through the troposphere, and then it reaches the ground, and it's shortwave rays, right? Shortwave radiation. And it hits the ground and warms it, makes it warmer. and the ground becomes warmer. And then afterwards, the radiation isn't short-waved anymore, it's long-waved. And yeah, so the radiation changes. This radiation of warmth. And we can feel that when, for example, we're sitting on a warm stone that's been warmed by the sun, and then we can immediately feel that physically. But you don't necessarily have to feel it, but it happens, it goes back up. And so what happens now? We have, for example, carbon dioxide at some point in the atmosphere, and there's also people saying that hydrogen steam would be more responsible, which of course it isn't. But yeah, so shortwave hits the ground, long wave radiation emitted from the ground wants to leave the planet, but is hindered, is blocked by all of those greenhouse gases. And thusly, the warmth stays within the system. And that's normal. And it's great that, that effect happens that way. Otherwise, it would be way too cold and we wouldn't be here. So just look at the moon. There's no climate gases on the moon, no greenhouse gases. And so where the rays of the sun hit, it's way too hot, and where it doesn't shine, it's way too cold. And so there's no buffer, right? Just like our atmosphere.
Now, this situation is something that we've known for a long time. To ignore or deny the effect of greenhouse gases is senseless. We have known this since our school days for centuries. And it's totally stupid to actually have to work it out and outline it in this way, because as a meteorologist, this is completely natural to me. I work with these effects all day. But now comes the transfer of that knowledge. If this layer of greenhouse gases is warmed because it is reached by the radiation from the sun, what happens? Well, it makes this layer of greenhouse gases more dense. And if that happens, the Earth heats up. This is what we do. If there was a marketing concept for this, if we were to write it down, and I said, okay, I have an idea, I'm going to dig up something from the ground that the Earth has separated millions of years ago. These are substances that have been separated out and buried underground and physically separated. And what do? We get the stuff out of the ground and burn it and add CO2, carbon dioxide, to the atmosphere that has no role in it, that has no place in it, hasn't been there for millions of years. So this concept of running combustion engines with this or heating apartments with it is completely absurd. And by saying that, I acknowledge that many of our cultural achievements are because of the fact that we've had cheap energy. Our achievements can be traced to burning these fossil fuels. That is linked to all our cultural efforts, achievements in the last 200 years. I'm not going to deny that, but there's something that we have not done, and we've missed the moment where we should have stopped when we understood that this was not a good thing to do. This is not a leftist green kind of narrative, it's physics. We've known this since 1824. Hang on, isn't this 2024? That's 200 years. Joseph Fourier, 200 years ago, a world-famous mathematician. Anyone who has something to do with mathematics or natural sciences made the first deliberations on this. He wrote a very short, strange piece. It takes a lot to understand what he wrote at that time, the calculations he made, derivations that he made. So, in 1824, a time that is quite removed from today's political and social reality. Now, if I say that climate science and the findings it has made is pushed towards a certain political corner, that is highly problematic because everyone depends on that. And physics, and that is the key sentence that I've repeated over and over again, physics applies to us all. No one can escape it. And Harald Lesch, to incompletely quote him, says, physics also applies if you've chosen not to learn it in school. And that is true. Even if you're not interested, you are affected. There are various reasons for choosing your subjects in school, of course. But even if you're not interested, the laws of physics are valid. That's actually just the introduction. So now let's see how thick this atmosphere actually is. And for that, I have a different image, again from NASA. And that is this one. Which personally I think is a fantastic image because you see various features. You see how incredibly thin the atmosphere is, but what you actually only see when you look here, I don't know if you can actually see it, this is actually a cloud that reaches up to the troposphere, the upper layers, such as thunderclouds do. These thunderclouds go higher and higher up, and then they are kind of stopped at the beginnings of the troposphere. So steam, water vapor, doesn't normally reach those upper layers, and you can see that the cloud is kind of cut off. So how thin the atmosphere is made quite clear in this image, I think. And there are various features that you can see, various layers. You can see the sun being reflected on the layers of cloud. You actually see that it's an incredibly thin layer, and we are polluting this thin layer with our carbon dioxide and increasingly with methane. So we are actually responsible for this. We cannot say Earth is huge and we cannot influence it. That is a stupid thing to say because we've changed the surface of the Earth fundamentally already. So the way we live, the way we do business has changed the Earth massively, at least the surface. We use minerals, we build things, we use anything that the Earth supplies us with, and everything we use is the foundation of our existence. This is the Earth that we exist on, and it's all threatened. There's another image that is even more instructive or beautiful, I think, and that is this one. Again, very beautiful, because you see from the side how thin the atmosphere is. You have the sun against you, you can see the space, and what you actually see, it's incredible. That's everything we have, everything that we have to exist on. I'm so fascinated by this, aren't you? Now, this is an image that many of you may probably know. If you show this, Stefan Rahmsdorf made it a professor, one of the most eminent climate scientists in Germany of our time. He's often attacked massively by climate deniers. If you show an image like this on TV, you have a storm against you by climate deniers who think up all kinds of ways of attacking this image. It's this so-called hockey stick curve by Michael Mann, who has had a lot of stress because of this too from science deniers. But sadly, this graph shows us the truth. It has been proven to be true by various studies. And what do we actually see? On the horizontal axis, you see time. 0 is the turn of the era, the Christian era. And in this area here, in this region here, what you see is the Holocene. And this Holocene is what we can thank for the ability to settle down. You may have learned this in school. The climate has stabilized in this period. It wasn't as volatile as it used to be. What you see earlier on is the Ice Age. And the change from the Ice Age to the Holocene, this rise in temperature, that was about as much as we may be facing if we continue emitting the way we do. It's exactly the same temperature change, but in an amazingly short amount of time. And that is the point. What is global warming? What is the climate crisis? The problem is that it is too fast. No one can adapt, neither plants nor animals, not even the sea level, because it has this inertia, it rises slowly. This happens in a long time, over a long time, hundreds or maybe 1,000 years into the future, until the sea level will have reached the level that we probably have, we have forecast, for example, with a 1.2 degree temperature rise. But let's look at it more closely. We have reached a point of 1.2 degrees, and at those 1.2 degrees, we have all the events that we've seen outside: extreme weather, massive melting of glaciers, be it in the mountains on Greenland, in West Antarctica, which, by the way, West Antarctica is a certain tipping point that cannot be stopped. If this ice melts, this ice is in the water, and the water that has slightly been heated already, it keeps on nibbling on those masses of ice, and it's melting the ice sheet on West Antarctica from below. So you don't have to imagine it 30 degrees warmer or something. It's just a little bit warmer, and that is just enough to melt these sheets of ice. And that is a problem, because if West Antarctica, the ice sheet on West Antarctica should collapse, that will cause the sea levels to rise much more. And this, through sea streams, is connected to Greenland. So the melting of ice in these two very far areas is connected. And that will make the effect so much stronger, and that is a real threat. So this is what happens with 1.2 degrees. I don't know if any one of you can imagine what it means to reach 1.5 degrees, which we have actually surpassed last year for a short time. You have to understand, this is no long-term development. We actually don't know what is happening. The temperature is going to go down slightly, probably over time again. We will see next year or the year after. Now, once we finally surpass the 1.5 degrees, which we were planning to not do until the end of the century, we're going to limit the rise to that. We may see this happening by 2030 or in the 2030s now. The final surpassing of the 1.5 degree mark. And you might then wonder, why did the Paris conference actually agree on this limit if we cannot actually stick to it? That is a question you could ask. Or why didn't we do anything possible to stick to remain in these 1.5 degree limits? So the question now could be, do we give up? Okay, we've surpassed this. No, the way you could see it is this. If we cannot keep to the 1.5 degree mark, we could still do everything as if we had kept to that mark. And then at least we could prevent things from going any worse, but we don't see this kind of action. And this is why I like to show this image. You can be as complex as you can about it, but this is where we could end up, and we are on course for 3 degrees now. If the states of the world actually implement what they
Also 3 Grad, keine Ahnung, was das bedeutet.
Pretend to do. No one knows what that means, though, arriving at 3 degrees. What the weather will then look like. As a meteorologist, I'm interested in the way the weather would then look like. I do not have the fantasy, I have to say. And I will show you some examples. I only have half an hour left. I have to hurry a bit.
Yeah.
Das hier finde ich sehr spannend.
So this is very interesting. I'm going to show you.
Das sind Klimadaten, die von Musikern
This is climate data interpreted by musicians. So how do you have to imagine that? You hear a bass note, a reference point, and then a string instrument will be like cling, 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 cling. And those are the average data points. And this is from late 2016, so we're missing the last 8 years, but you can imagine it to sound the same.
Boah, also ich muss sagen, ich kriege da eine Gänsehaut.
Whoa, it really gives me chills.
Also man kann natürlich auch darüber nachdenken. Also ich finde das echt heavy.
Yeah, so this is really heavy stuff. So when you think about how do you present, data to the public, I think that's a really good example because, the sound, it's an alarm sound, right? And it's not alarmistic. So you can hear the sound, the notes rising, right? And then it's just like bursting through the ceiling. And yeah, it's really well made. So for quite some time, we've known what's going on. And the connections, as scientists, we can explain it going back for a few hundreds of years. Physics, that applies to us all. And you see the German news broadcast Tagesschau, and the older people in the audience might recognize this is an old version of the show. But the images you're going to see, they're basically the same as today. So, planes taking off, cars burning fuel. So usually, you can ask, do you want to guess which year that is? And I'm going to tell you straight away, it's 1979. I don't know. Please raise your hand if you've been alive in 1979. I was 8 years old back then. So as a child, the adults back then could have reacted, could have done something about this, from my point of view. So, what might kids today feel like? So we're going to take a look. What the long-term development will be on the weather and how the climate of the world will be in the future. There's a conference in Genoa dealing with that. Not just the weather, but the whole climate seems out of bounds. This is the topic of 100 meteorologists that gathered in Genoa for the first climate conference. 200 forestry and agriculture experts listened to them interestedly. Measurements in the Atlantic shown that the carbon dioxide levels in the Earth's atmosphere continue to grow. And this growth is the result of all of the oil that's being burned by human emissions. And as well, we've seen that plants are going back. For example, all the forestry happening in Brazil might influence all of the Earth's climate. And the rising levels of carbon dioxide lead to side effects which we do not want to have. Professor Flohn from Bonn held a talk. If the Arctic ice would be to vanish completely, we would have the sea level shift 500 to 800 kilometers south, and our climate would change. And so southern middle Europe, there would be so many changes, and the water supply and our agriculture and crops, what would happen to them, we can't tell at all. Yeah, so that was 1979. And now my computer's doing something it shouldn't be doing.
It's a Mac.
Yeah, sorry, it's not reacting, not responding anymore.
Das ist natürlich Worst-Case-Szenario, wenn der Rechner nicht mehr das macht, was er tun soll.
Yeah, please give me a minute. All right, let's continue. So for quite some time, we've known about these developments, and the images we've just seen, are the same that we see in the present today, and what is happening in the present today. The climate regions are changing. Areas with a milder climate are becoming hotter. And last year we've had the situation that was extraordinary when in Germany we've had this high pressure area, and of course, and on the side of this high pressure area there was a low pressure area in the Mediterranean area in front of Greece. And that's something us as meteorologists reached the limits of what we're, able to predict, these extreme weather scenarios. Is it even possible? What our, statistical models tell us will happen? And it predicted a rainfall of 700 to 1,000 liters per day within 3 days. And that's the amount that it usually rains within a year in a German city. Yeah, sorry, I'm going to restart my computer so that we can continue. Apparently, my computer also couldn't handle the hard truths that Professor Flohn was telling us about. All right, it's booting. So we were sitting in front of our computers and looked at the models. And it wasn't only like one model for one point in time. Instead, we looked at various models for some hours, like every 3 to 6 hours, the models, keep being remodeled. And so we get new results each time. And so we looked at all of these models that were being produced by our computers, and we really couldn't grasp the amount of rain that was predicted. All right, now I have to log in.
So.
All right.
Diese Modelle waren wirklich extrem.
Yeah, so the progression that the models showed were so extreme. And how, can it be more than 1,000 liters? That's like tropical. That's not possible in the Mediterranean. That's just something you know as a meteorologist, right? And so this was a really interesting discussion, which we didn't have before. And then the rainfall actually happened, and the amounts that were predicted actually happened in reality and led to massive flooding in Greece. And, there were in agriculture areas, on streets, there were these lakes suddenly. And it was measured up to 750 liters. And then, electricity broke down, internet broke down, and then the measurement stations weren't able to produce any more data due to the flooding. And so it stopped at 750 liters. So per square meter. And so it's really masses of water. And not just in the Mediterranean, and it's not just about the change in temperature, but also the surface area of the ocean. It becomes much, much warmer, and that creates a lot of vapor and a lot of humidity. And then once a low pressure area comes in, it just soaks it up. And so when water vaporizes, the warm air can, take in all of this humidity. And then you don't see anything maybe. Maybe it'll be a bit humid in the air, but you don't see it, this development. But what happens if the air is forced to rise? And of course, that's, a typical meteorologist speaking. What happens when something lifts up the air? Then there's a certain level of condensation. And now the humidity steps into action. And so the humidity captured in the air, we call it latent warmth. It's a form of energy that only takes action when there's condensation. So it's from gas to liquid, if you remember your physics and chemistry lessons from school. And that releases warmth. And then the cloud uses this warmth to keep growing. And that's a normal development, a regular phenomenon. And it happens all over the world. But now, the transfer to this case last year, what happens when there's more humidity, more warmth? So those are the preconditions that I realized months before that, the first time a low pressure area will come into such a situation, it will be catastrophic. And that's just what happened there in Greece. It turned around, yeah. So it's not just my computer that's having problems this morning. I'm gonna check. Yeah.
Jedenfalls, ist auch gut zwischendurch mal zu lachen, auch wenn das Thema so ernst
ist. Yeah, it's good to have a laugh in between, even though the topic is so serious.
Dieses Tief hat einfach.
So this low pressure area used this energy, this humidity, and there were thunderstorms being created by the low pressure area. And then near to the mountains, all of the water came down. And that's the problem with thunderstorms near a mountain range. It's just the same as with the catastrophe in the Ahr region in Germany, where there also was flooding. And you never notice like these small streams, these very small rivers. But then at some point, you're so surprised when that suddenly becomes a giant streaming river. And so, and then there were these discussions, do you rebuild cities and villages in certain areas that were flooded. Should you? Are we able to? Do we need to adapt to the climate? And so, yeah, that wasn't the end of it. The low-pressure area just didn't disappear. It kept growing. It kept increasing in strength. It traveled across the Mediterranean Sea and hit Libya. And in Libya, it was a real catastrophe. You know, they have a bad infrastructure. Dams were breaking, and it was just so much water that, you know, it crashed their infrastructure. And at least 5,000 people died in Libya due to the flooding. Cars being washed out to sea, and just horrific images. And so I often use the term climate catastrophe. And of course, you know, that's already a reality for some people. Of course, we here in Germany can say, oh, it's not that bad, right? And that's really egotistical of us. Because, yes, it is that catastrophic. It's not just locally. It's the whole system, the whole planet is shifting and changing. And the preconditions for our life flourishing on this planet, you know, is breaking apart. So my laptop is back, yay. And now I'm going to talk about the amounts of carbon dioxide. Yeah, maybe we can switch again. I think it's working.
Dachte ich.
Well, I thought it was back. Here we are. Okay. Thank you for the applause. Are you applauding the technology or me? Oh, well, how stupid. Anyway, so what we see is the concentration of carbon dioxide. You can get this from the internet, so I'm not going to get into much detail. You don't have to click into a presentation. It's on the website. But you can't see that much. But what you see is a certain 426 ppm, parts per million. And how long has it been since we've reached those kinds of levels? Let's see.
Ja, würde ich gerne machen.
Well, I would love to, but well, since we've rebooted the computer, just to explain, there's something still missing, but I'll keep on talking anyway. Well, the biggest challenge is actually to cope with technology, right? So the carbon dioxide concentrations is rising, and it keeps rising faster and faster. The rise is accelerating, and that, as we've seen, is a huge problem because things get warmer and warmer. And I'm now going to try to load this. Yes, it's worked. What you see is the last 6 months here, and you don't really see a trend here. You see a rise, but that is actually connected to the seasons that changed the strands throughout the year. When plants start to draw carbon dioxide out of the atmosphere because they are in bloom and plants are growing. On the northern hemisphere, this is the northern spring. Then carbon dioxide is being extracted, and later on, you see, well, what we see is a wave kind of line. And I'll show you this. This is the course throughout 1 year. You can see that wave now. You can see the low and the high points. And now we see 2 years, and you see that in the beginning, that the value is actually lower than it is at the end. And now the full record. Since the beginning of the recordings until the present, we see a rise of CO2 concentrations. Of course, and what could this be down to? Well, if we keep burning coal, oil, and gas, it's very clear. What we also see here, what we see now looking back the next 2,000 years.
Die letzten 2,000 Jahre.
So that was the last 200, now it's the last 2,000. And what you see now is actually completely catastrophic. So up to 10,000 years back, actually, let's go back a bit further. It's still 800,000 years. And here you see the various ice ages and so on. And until 800,000 years back, the modern human being, Homo sapiens, if he is sapiens, goes back around this amount of time. And this is us at the end, clearly. This value of carbon dioxide concentrations hasn't existed for all this time, 800,000 years. Now, there's a current research project in Antarctica where they are drilling ice cores and extracting them, and they see the concentrations in the ice, and that's what they analyze. And with that, you can see how things are changing. This project is going back 1.5 million years, and it's important to say that we know how things were actually. Climate science is actually complete in a sense. We have all the instruments for action too. But I did also want to show you some examples, which means that I will really have to see how to proceed. In theory, we could now close this, and I'll show you. It's actually just 12 minutes left. I'll have to hurry a little. And I'm slightly afraid of just starting this video now.
Also, ja.
Right.
Also eine Sache mit der latenten.
So, the one thing about latent heat is something that I want to explain. This.
Okay.
Here we go. We have lost the sound too. Oh. Oh dear, how terrible.
Das ist ja eigentlich der Worst Case, ne?
Well, that's actually the worst case, isn't it? The computer just stops working during the talk. What worse things could happen? So currently, the average is 21-something degrees. So extreme weathers might reach us too. The air takes up this moisture, and warm air can store more moisture. If this rises, it reaches a height where the moisture condenses into droplets. A cumulus cloud forms that continues developing, and while during the condensation the stored heat is set free and the cloud keeps growing into a massive thundercloud, a cumulonimbus. The more condensation, the more heat is released within the cloud, and that leads to a thunderstorm. Yes, and that is an example of the way we work at the broadcaster where I work, ZDF, the German public broadcaster. We explain certain connections, and that is our job as meteorologists, to depict reality. And I see that we have about 10 minutes left, and I promised that I would stop with something that is nice, where we can have a laugh. But I promised I was going to give you the downer beforehand. We as scientists, meteorologists, talking about these things, we know that we are being attacked a lot, and I was asked to talk about this too, and I'm happy to do that. I'm not just doing that for us, but mostly for those that will come after us. Because we've seen at a meeting of meteorologists, those that are in the limelight and that put the weather and the climate together, these are people that are reaching the age of 60 now. So it's easy to see when they will not be in those jobs anymore. But we need more people to come. We need students of meteorology that study these things. We need people that explain this in public, in the media, everywhere. We need meteorologists that deal with both these issues. For one thing, the scientific side, communicating this, global warming and the connections to the weather, but also the social implications, so that we can all see the bigger picture. And I found it important to talk about this because one colleague said, well, these few climate deniers, they are loud and they cause a lot of stress, but it's not so many, right? Now, if that were not actually effective, the way they talk, then we would respond in a very different way as a society, wouldn't we? And I have to briefly explain. This is Ingolf Bauer, who presents a program on the broadcaster Dreisat called Nano, 3Sat. And this piece he was asked to do for the North German broadcaster NDR. And they talked to me. Isabel Schneider talked to me, and she had a piece about Carsten Schwanke and myself to keep this communication going. But we are not the only ones. I don't intend to put myself into the center so much, but it's about people being chosen that work with public broadcasters as representatives of the whole thing. So let's just watch this. Those that don't want to hear anything about the reality of the climate and like to just cause hatred and polemics, they are becoming more radical, and the pseudo-arguments of the climate deniers are being held up. The more this happens, the stronger they defame individuals, those that carry this message. Two weather presenters tell a tale.
My name is Özden Terli.
My name is Özden Terli. I work at ZDF. I present the weather, and I am a scientifically educated meteorologist. Well, I would call myself a TV meteorologist and a science journalist. Let's now look at the amounts of rain that have come down in the last three days. Some of us have actually seen more than 400 liters. Climate change is not a local phenomenon, it is global. The issue of the climate is not just important to me, but to all of us. It is not my personal issue to talk about these things. I am actually compelled to talk about this as a meteorologist. Of course, the climate and the weather are two different things, but the system of the climate that is changing has an effect on the weather, and that changes the way the weather systems work. And that connection is very important to explain. This is not a natural phenomenon. It is caused by us humans because of the way that we live on the planet, make business on it, and change it. And what's also dangerous to diversity is the heating, the warming, that has now reached a value of around 1.2 degrees. If we did not have any carbon emissions from humanity, then the temperature on the whole of Earth would have kept to this kind of range. Last July was the warmest year since the beginning of recordings. What we see as extreme today, in about 10 years, will be the norm. There's a strong front of people that loudly fight against this, call it all a lie, and then I am called to say, no, it is true. We can see it in the measurements, and these measurements are correct. The comments, the attacks, I think, has changed in the last few years. While a few years ago it was only meteorological, climatological facts, the debate has shifted onto personal attacks. Schwanke. We were able to believe in him in the past, and I used to like him, but now he's part of these politically motivated figureheads. It starts with harmless, I don't believe you, or you will see what will come of this, threats, basically. But there are racist, offensive remarks, too. No matter how the weather is, it has to be put into this climate ideology. Is Schwanke being paid by the government? In which party is Schwanke active? All these people that work in the state media are left-green activists. I don't know what to say. I don't know where I was turned. This kind of guy calls himself a meteorologist. He is a system blabber, nothing else. I used to think that you're intelligent and you know what you say. I'm not going to read this. It is really below the belt. Another rented mouth that you don't have to listen to. Oh, delete meteorologist and add ideologist. it doesn't need to be commented. The public broadcasters are going to continue until the mob will chase you out of the country. Now, that, I think, is a new level. The mob is supposed to chase us out of the country. Well, you try to report, they try to suppress reporting by discrediting those that do the reporting permanently. Yes, it does use strength and energy, and there are days that are really get down. And it has come to the fact that I've blocked comments by now. Climate protection, even in conservative circles, is now being depicted as something leftist, greenist, and that is a huge problem that this label has been put on that, because then I lose an important part of the conservative society if they say, I'm just not going to deal with these leftist, greenist things. I don't like that bad conscience that people are giving us all the time. At the end, we decide what we want to do, and not a few leftist, greenist functionaries. We can only bring our country forward with concrete suggestions, not with the climate blah blah. Every one of us takes the climate protection issue very seriously, but we're not doing it in such an alarmist way as the government. And the environment is not going to be breaking down tomorrow. That is our thinking. I once tweeted physics is leftist as a provocation because, of course, physics is not that. There are days where I feel that I'm part of a fight, I have to say. We're not moving forward if we keep these fronts, if these fronts keep deepening. And I don't want to be part of this, actually. Sometimes it is a struggle, sure. It's this permanent positioning and trying to hold against it. And of course, it makes no sense, this kind of fight. The climate crisis, global warming cannot be denied. This is a fight that the other side cannot win because physics is physics. And I believe that scientists, meteorologists, journalists should actually fight back against this and shouldn't tolerate everything. We have to defend ourselves if facts are not taken seriously anymore and boiled down. Then we have a huge problem in society that goes far beyond the issue of science denial. Yes, and that is something that we at Nano stand for, of course. I believe what Ingolf Bauer says at the end, they are standing for that at Nano. Of course, it's a science program. But that's not the way I want to end, and I did promise that we would have a real laugh about science deniers. Let me see where this video has gone. Oh, hang on. Oh, God. I'm going to search it. I don't care at all. Let's have that video. Here it is.
Can you explain to people like President Trump how
Okay, so I believe that I have to come to the end. I'm here already, but I'll just keep standing here for a while. Thank you. Okay, we've seen two videos at the end. The one shows you the problem, shows what problems we have, and the other just to give you a laugh about it. But the problem is, it is just too hardcore, and we have to deal with it more so that we can actually reach solutions, and so that we are not just frustrated completely. But this is only possible if we deal with it. If we ignore it, the problem will only get bigger. Thank you for your attention.